Assalamu alaikum. Welcome to lecture 14 of Software Requirements Engineering, CSE305. In today's lecture, we are going to continue our discussion on the elaboration process, which is one of the sub-processes of requirement engineering process following the elicitation process. And let's quickly recap what we did in the last lecture. We started talking about object-oriented analysis. And we have been actually discussing object-oriented analysis for the past two lectures, and we said that there are multiple modeling approaches that we can use when we are using object-oriented analysis for elaborating requirements. And the first one we saw was scenario-based modeling, in which we looked at the use case diagrams, we looked at use case text, and we also looked at activity diagrams and the swim lane diagrams. And the important thing was to understand that as a requirement analyst, how these tools or how these diagrams or how writing a use case text would help me understand about the functionality of the system, about behavior of the system, and about the information domain of the system. Specifically, we saw that scenario-based modeling was helpful in identifying So first thing we know about scenario-based modeling is that this is from user's point of view. We try to understand the system from user's perspective. So that we know that it gives us the user's perspective. So it helps us understand what are the functionalities that our system should possess when a user tries to interact with it, and how our system should behave when the system when a user is interacting with the system. So it helps us understand the functions and also the behavior in response to the user interaction. So two things we know from the scenario-based modeling. And we also saw that when we write those use case texts, then at times we also sort of identify some non-functional requirements. If you guys remember, there was a specific section on specific requirements. So we can identify some non-functional requirements along the way, but the goal here is to identify functionality and behavior of the system from the user's perspective. And then we looked at the activity diagrams, we also looked at the swim lane diagrams, and we said that activity diagrams, they basically are a very good way of representing that in what order different activities or different events would go. For example, when we write use case text, then we mention alternate flows, we mention exceptions in the normal flows, and activity diagram is a very good representation of actually visualizing that. Similarly, we move to swim lane diagram, and it's just a different way of drawing the same activity diagram. What we try to do is that we try to group those activities in different lanes, and each lane belong to a typical actor. So an actor, as we said, an actor can be a person, it can be a system, or it can be another machine. So that was scenario-based modeling, and we saw that it helps us in identifying functionality and behavior. Then we moved to another modeling under object-oriented analysis, and that was class modeling. And specifically in class modeling, what we looked at was, so in class modeling, so the first one was scenario-based modeling, and the second was class modeling. So in class modeling, what we looked at was class diagrams. Okay. And when we say class diagrams, what we mean here is that we try to identify information domain classes, and how do we do it? And this is actually common across all these modeling approaches. That just remember that this is our elaboration process, and before it we have done an elicitation process. Now we have said that, you know, one of the output of elicitation, there can be multiple outputs of elicitation, but let's say it will be in the form of, you know, multiple scenarios. So we have this scenario, we have another scenario, so we have sets of scenarios, you know, and depending on which technique we use to elicit requirements, we have different scenarios in different formats. So this is an input to all these kind of modeling. So these scenarios or these stories that we have written, they are input to these modeling, and moreover, for example, when we are doing this class-based modeling, then if we have done scenario-based modeling or scenario modeling before it, then the use case text, this is also an input to the class modeling. Okay. So what we do is, when we want to identify those information domain classes, is that we try to do a grammatical parse. because all we have at this stage is some written descriptions about the system. So, and we do not have any other information. So what we do is we try to do a grammatical parse, and we do two grammatical parse in particular. So the first one, we try to identify all nouns. We identify nouns and we identify nouns clauses. And the goal here is that all these noun clauses, we classify them as our potential classes. Right? So we say that all these nouns, they will be our potential classes. But this word is important, that we are saying that these are potential classes. These are not the actual classes in the solution, because in the text that we write, or whatever scenarios we have from the elicitation process, they might have too many nouns, and all the nouns cannot be classes, because it will result in an inefficient and badly designed implementation. So it is very important to actually select few of those potential classes as actual domain classes. But how do we do it? So there were two things involved in getting from potential classes to the actual domain classes. The first thing was to actually classify those potential classes. So the first thing is classifying these potential classes. The second was passing each of these potential class through a set of criterion, and each potential class should satisfy all those conditions to actually be considered as a domain class. So what were those classifications? We saw that there are multiple classifications. A class can be classified as an external entity, it can be classified as a role, it can be classified as a thing, it can be classified as a place. So there are multiple classifications. In total there were 7 classifications. And if we looked at the criterion, so the first thing is that we identify a potential class. For example, it's a sensor. So we say a sensor is a thing, and then we say, okay, then what are the different criterions? So that we said that there are multiple criterions, and those criterions are retained information. So whatever a domain class we would have in our system, there should be a need of storing some information about the instance of that particular class. And similarly, the class should need some services. So the second condition was that it should need some services. The third condition was that it should not only have just one attribute, it should have multiple attributes. Then different instances of class should have common attributes. And the fifth one was it should have some common operations. And the final was final one was it has some essential requirements. So there were 6 criterions, and we said very specifically that each potential class should satisfy all those conditions in order to be considered as a domain class. But there was one exception, and the exception was that if a class is classified as an external entity, if a potential class is classified as an external entity and it is an essential requirement. By essential requirement here I mean that your system won't be functional or won't be complete without it. For example, in our case, in the example that we looked at yesterday of the safe home product, without the alarm the whole system is kind of useless, because if somebody breaks in and there is no alarm, or if there is fire and there is no alarm, then it won't actually serve its complete purpose. But alarm, it does not satisfy all those 6 conditions. So, but because it's an external entity and it is essential to our system, so we will make it a domain class. So it's so there is just this one exception. So that was the first grammatical parse, and we said that we do 2 grammatical parses. So the second grammatical parse, if you see that at this particular class diagram, then this class diagram it tells us it shows basically that this is a class. And this is how we represent classes in UML and various other modeling tools. So this is the class name system, and this class has passed those 6 criterion, and we have selected it as a class. But if you guys remember, then a class has 2 other things. It has some attributes, and as we said that a domain class should have multiple attributes, so it has multiple attributes. And it needs some services. So every instance of the system class or instance of the system class would need all these services. And these services are different operations. So we have different operations as well, and different instances would have some common attributes, and it would have some common operations. So this is our class, and we have already seen that how we came up with a class. But how do we identify these attributes, and how do we identify these operations? Now the attributes, they would be identified through the first grammatical parse. So the first grammatical parse is used to identify the attributes. Because if you remember, I said that there are lots of nouns that you identify, and we call them potential classes. Now from those set of potential classes, so let's say this is the set of potential classes, we have identified few domain classes. Now the remaining nouns here, nouns and noun clauses, they become the attributes of different classes. So what we do is that we try to match those attributes to different classes, and the closer we think that this would describe an instance of this particular class, we make an attribute of that particular class. Then how do we identify operations? To identify operations, we need to do a grammatical parse, and the purpose of this grammatical parse is to identify verbs. So what we do is we try to identify all the action words, because all these action words, they actually mean that some action would be taken, and those actions, they are basically on the attributes of these classes. So for example, in this particular case, for example, programming mean that you're programming the system, displaying mean that some information is displayed on the panel, then you reset the system, you have a certain query, you want to modify your master password and maybe other information, or you want to make a call. So we identify all these operations by identifying different verbs, and what we do is we will have a big set of verbs, and again we do something similar what we did with the attributes. We try to relate those verbs to different classes to identify operations of a certain class. So this is how we identify the information domain classes. We identify their attributes, and we identify their operations. But again, as I said, the purpose here is not to understand class diagrams, or not to understand how to make a class diagram, because we didn't discuss that how you connect different classes, what are the different kinds of association between different classes, because that is already covered by you in your other courses. The purpose here is to understand that from an analyst point of view, what information you are gaining from this whole class-based modeling. Because remember, this is not designing, we are at the requirement engineering, we are doing requirement engineering, and if within requirement engineering we have not even yet specified requirements, we are trying to analyze requirements. So remember that there are three goals why we want to do this analysis. We want to gain understanding about the information domain, we want to know more functionality of the product, and we want to understand the behavior of the system. So if you look at this particular class-based modeling, then if we just want to tick that what this class-based modeling is helping us in, so it actually is helping us in understanding the information domain, because we are identifying information domain classes through it. It is definitely helping us understand the behavior of those classes, because when we apply certain operations on these classes, then the behavior of the class would change. And similarly, it is also helping us understand the functions. So it is mainly the class-based modeling is helping us understanding the information domain. Okay, the scenario-based modeling was more towards functionality and behavior from the user's perspective, whereas class-based modeling is more towards information domain, because we are identifying information domain classes. We are trying to understand the behavior of those different classes by identifying different operations of those classes. But this is not all that we do in in class-based modeling, because the next thing in class-based modeling is that we have identified different classes, but how do you know that where and when these classes are going to talk to each other? Because in a complete solution, you have different classes when you are following this object-oriented approach, and you have those different classes, but those classes also talk to each other. So how do we actually get to it? There is a technique which is called CRC modeling, which is called Class Responsibility Collaborator modeling, and this is something that we are going to cover today along with the other modeling approaches. So let's quickly see what we have in store for us in today's lecture. So again, we are continuing with object-oriented analysis or object-oriented approach for this analysis or elaboration process, and we are going to finish our discussion on object-oriented modeling. As I said, we are going to look at CRC modeling in particular.